Okay, real zeros of polynomial functions. This is something you've done last year. It's called the rational root theorem. I think our textbook calls it the rational zero theorem, but remember we talked about that. Zeros and roots are the same thing. They're all x-intercepts. And we're going to use our calculators to cut back on some of the long, tedious work on these problems, and you'll see what I'm talking about later. First, the rational root theorem is the one that says if you have a polynomial with a rational root, and remember rational means it can be written as a fraction of integers, so written as some number over some number, like 2/3 or something like that. If you have any rational functions, it could be written in the form p over q, where p is a factor of the constant, the very last term, q is a factor of the leading coefficient. And we'll just do some examples of this, show you what that means. We have two polynomials here, and I want you to list the possible rational roots. And you start by looking at the constant. I'm going to write all of the factors of 20, which are 1, 2 goes into 20, 3 does not, 4 does, 5 does, 6 doesn't, 7 doesn't, 8 doesn't, 9 doesn't, 10 does, and 20 is the last one. So those are all the factors of 20. My leading coefficient is 1, and my factors of 1 are just 1. So to list my possible roots, I should specify that they're possible because every one of these won't work. There's only a few of them that might work. I'll just do factors of 20 over factors of 1. So I'm going to start with 1 over 1, which is 1. 2 over 1, 4 over 1, 5 over 1, 10 over 1, and 20 over 1. And their negative counterparts, so also negative 1, negative 2, negative 4, negative 5, negative 10, and negative 20. Now, all of these are not roots. If you remember, we talked last week or earlier this week that the degree tells you the most number of roots. So there's a maximum of 4 roots. So of these 12 that we listed, only 4 of them at most could work, and maybe not even that many. Sometimes we'll have irrational roots or imaginary roots. This is only for rational roots. So those are the possibilities, and that's all I wanted to do with number 1 is list them. Number 2, same thing. We're going to list the possibilities starting with factors of 12. 1, 2, 3 goes into 12, 4 goes into 12, 5, 6 goes into 12, and 12 goes into 12. And then I'll list my factors of 4. 1 goes into 4, 2 goes into 4, 3 doesn't, 4 does. This is going to have a lot more possibilities. I'm going to start listing them. My possibilities are 1 over 1, 1 over 2, 1 over 4. And while I'm doing this, I'm going to go ahead and just say plus or minus, because we could do the positive or negative of each of these. So I've done 1, and I'm done with it. So now 2 over 1, which is just 2. Whoops. Plus or minus 2, plus 2 over 2. But 2 over 2 is equal to 1, and I already have 1 listed, so we really don't need that one. And then 2 over 4. 2 over 4 is 1/2. Oh, I already have 1/2 also, so we actually don't need 2 over 4 either. Let's see. Going on. 3 over 1 is 3. 3 over 2. 3 over 4. And then I'll move on to my 4. 4 over 1, plus or minus 4 divided by 1. Plus or minus 4 divided by 2. But 4 divided by 2 is 2, and I already have that listed. And plus or minus 4 over 4, which is 1, I already have that listed. So let's go on to 6. So plus or minus 6. Plus or minus 6 over 2, which is 3, and I already have 3. Plus or minus 6 over 4, which reduces to 3 over 2, and I already have 3 over 2. So then I'm down to plus or minus 12 over 1, which I don't have yet. 12 over 2 is 6, and I have that. And 12 over 4 is 3, and I have 3 listed already. So these are all of our possibilities. And if you want to write the repeated ones just to make sure you don't mess up, go right ahead. I certainly won't count off. But if you recognize, like when I did 6 over 2 in my head, I just kind of thought, okay, well 6 over 2 is 3, and 3 was already listed. So I didn't bother writing the 6 over 2 possibility. But if you want to write it, you can. And those are all the possible rational roots for number 2. So once we list the possibilities, then what I'm going to want you to do is actually find which ones work. So here's an example where we're going to find the ones that work. And I'm going to start by listing my factors of 12, which are 1, 2, 3, 4, 6, and 12. and then my factors of my leading coefficient, which is 1, and then my possibilities, my possible roots are plus or minus 1 over 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Now we have to decide which ones of those actually work, because we can only have a maximum of 4 roots that do work. So what I'm going to do is I'm going to pull out my calculator, and I will graph, whoa, that's kind of in the middle of the screen, and I'm going to actually graph this. We're going to use a calculator to help us out here so we don't have to do all the mindless work. If you remember last year, what you probably did was synthetic division, and you put every single one of these in to see which ones work. Well, we're going to use a calculator to cut back on that work. So let me graph it real quick. And after looking at the graph, I have the graph sitting here next to me. It looks like I have a root. I'm hitting my x-axis at -2, at -1, and at +3. Those are what look like roots, and then we need to verify whether or not those actually are roots, and the way we test them is with synthetic division. So I'll do -2 into my polynomial, and I'm using synthetic, so I'll just write down the coefficients, 1, 2, -7, -20, and -12, and then I will bring down and do synthetic division. 0, 0, -7. -2 times -7 is 14. -20 plus 14 is -6. -6 times -2 is +12, and 0. And since I got a remainder of 0, that means x equals -2 is indeed one of my roots. So I'm going to hang on to that one. That one did work. Now when I try -1, instead of doing -1 into my original one, you can actually do synthetic division into what is remaining after I took the -2 through. Since -2 did end up with a 0 remainder. So I will do -1 into this one. I'll bring down my 1. -1 times 1 is -1. 0 minus 1. -1 times -1 is 1. -7 plus 1 is -6. -1 times -6 is 6. And again, I get a remainder of 0. So that means x equals -1 is a root. That one checked out also. Now I need to check 3. And since I did get a remainder of 0, I can just keep going down here. 3, bring down my 1. 3 times 1 is 3. -1 plus 3 is 2. 3 times 2 is 6. 6 minus -6 and 6 is 0. I got another remainder of 0, so that means 3 worked. So there's my other root. And I have 3 of my possibilities worked, but there should be 4 roots, right? There's a possibility of 4 roots. So what I'm going to do to find my last root, what I will do is, when I did my synthetic division, I ended up in the very end with 1 and 2. Now remember, 2 is a constant, and 1 is my x term. So what I can actually do to find my last root is I take that term, x plus 2, and I'll set it equal to 0, and I solve that, and I get x equals -2. And that is actually my 4th root, but we already had 2. So since 2 showed up twice, and maybe this is a little bit confusing, but that's what's referred to as a double root. And I didn't intend for that to happen on the very first example, but it did. And sometimes that's going to happen. Sometimes that'll happen. So we actually have 3 roots with -2 kind of counting as that hidden 4th root. So there we go. Let's try this one. Oh geez, this is going to have a lot of possibilities. Okay, so I'm going to list my possibilities. -18, factors are 1, 2, 3, 4, and 5 don't go into it. 6 does. 9 and 18, and then 12. Holy cow, what was I thinking? 1, 2, 3, 4, 6, and 12. And my possibilities, it's going to be quite a few. My possibilities, we're going to start with 1 over each one of those. So it's going to be plus or minus 1 over 1, plus or minus 1 over 2, plus or minus 1 over 3, plus or minus 1 over 4, plus or minus 1 over 5. Nope, not 1 over 5, 1 over 6. Plus or minus 1 over 12. And now I'm done with the 1 now to the 2, plus or minus 2 over 1 plus or minus 2 over 2, which is 1. I already have that, so I'll go 2 over 3. Plus or minus 2 over 4, which is 1/2. Ooh, I already have 1/2. That's good. Plus or minus 2 over 6. 2 over 6 is 1/3, and I already have 1/3. Plus or minus 2 over 12 is 1/6, and I already have that one. So actually, we didn't have that many out of the 2. So let's do 3. Plus or minus 3 over 1. Plus or minus 3 over 2. I don't have 3/2 yet, so I'll write that one. Plus or minus 3 over 3 is 1. I already have that one. 3 over 4. I don't have 3/4. 3 over 6 is 1/2. And 3 over 12 is 1/4. I've already got both of those, so let's go on to 6. 6 over 1, so plus or minus 6. 6 over 2 is 3. Already have it. 6 over 3 is 2. Already have it. 6 over 4 is 3 over 2, which I already have 3 over 2. 6 over 6 is 1. 6 over 12 is 1/2. So all of them with the 6, except for 6 over 1, were repeated. So let's do 9. 9 over 1. 9 over 2, I don't have that one yet. 9 over 3, 9 divided by 3 is 3, I already have that one. 9 over 4, I don't have that. 9 over 6 is 3 over 2, which I think I have, yep. And 9 over 12 is 3/4, which I also have that one. So then let's move to 18, plus or minus 18 over 1. 18 over 2 is 9. 18 over 3 is 6. 18 over 4 is 9 over 2, which I already have. 18 over 6 is 3. I have that. And 18 over 12 reduces to 3 over 2, which I have. So those are my possibilities. Wow, that was a lot. Now I am going to graph this. I'm going to go to my calculator and look at the graph and see where it looks like we have roots. Where it looks like we have roots. So I'm going to graph this. And here comes my graph. And it appears that my roots are at... Ooh, there's one really close to the x-axis. It's either -1/3 or -1/4. That's my guess. There's another one. It looks like around 2/3, somewhere in that vicinity. 2/3, maybe 3/4. It's somewhere just to the left of 1. And then it looks like I have another one coming down at 3. I think 3 is 1. Okay, so those are what I think my roots are. Now I know they aren't all going to work because there's only 4 possible roots and I have 5 listed, so I know they won't all work. So at least one of these is going to fail. Let's start with 3. I'm going to use the whole number first because fractions scare me. So I have 12x to the 4th, -77x cubed, 136x squared, -33x, and -18. I'll bring down my 12. 3 times 12 is 36, -77 and 36. I could probably do that in my head, but I don't want to make any mistakes. That's -41. That times 3 is -123. 136 minus 123 is 13. 3 times 13 is 39. -33 plus 39 is 6. 3 times 6 is 18. And I do get a remainder of 0, so that's good. That tells me that x equals 3 actually works. So I'm going to put x equals 3 as one of my solutions. Now the scary thing is that of the remaining ones, they're all ugly. So I'm trying to decide what I want to do first. I guess, let's go left to right. Let's start with -1/3. So I'm going to try -1/3. I did get a remainder of 0, so I can just bring -1/3 into this. We'll bring down the 12. Now I know this is scary, but if -1/3 is a root, this thing's going to end up being kind of sexy. So 1/3 of 12, punch that in the calculator, you'll get -4. -41 and -4 is -45, and 1/3 of that is -15. Positive 15, I'm sorry. Positive 15. 13 times 15 is 28. Okay, 1/3 of 28, I'm going to punch that in the calculator just for the sake of doing it. You get, 1/3 times 28. You get 28 over 3, or 9.3. And that's good enough for me to know that, you know what, that doesn't work. I don't get a remainder of 0. It's not equal to 0. So that tells me that negative 1/3 is not the root. So since negative 1/3 didn't work, what I'm going to do is go on to negative 1/4, but I can't use any of this work now because that negative 1/3 didn't work. So I actually have to start over back with this line right here and negative 1/4. So I'll come over here and I'll do that. Negative 1/4 into, and it looks like I've got, 12, negative 41, 13, and 6. And we'll bring down the 12 and we'll do synthetic again. 12 and a fourth of 12 is negative 3. Negative 41, negative 3 is negative 44. Times 1/4 is positive 11. 13 and 11 is 24. A fourth of 24 is 6, but I'm multiplying by negatives. That's negative 6 is 0. Hey, there we go. Got a remainder of 0. That means negative 1/4 worked. So I'm going to move that over here to my list of confirmed answers. Yeah. And then I'm going to keep looking, and I'm going to go with 2/3. We'll see if 2/3 works. So 2/3. Bring down my 12. 2/3 of 12 is 8. Negative 44 plus 8 is negative 36. And you can punch these in the calculator to help you out. That would end up being negative 24. 24 minus 24 is 0. So that is another remainder of 0. That means 2/3 works. And what I'm going to do, since I'm tired of doing synthetic division, once I get down to like 2 terms here, I have 12x minus 36. I'm going to set 12x minus 36 equal to 0. And if you solve that, you actually get x equals 3. So once again, we end up with 3 counting as a double root. That's rare. We have it 2 times in a row. So 3 counts as a double root, and there's our solution for that one. Wow, this is taking a lot longer than I thought. You good? You good? All right, we have 2 more, but the next 2 are not going to be as cumbersome. The next 2 are not going to be as cumbersome. So the only difference is here I'm asking you to find all roots, not just the rational roots. So I'm going to list factors of 36. And for the sake of cutting back on the video, I'm going to pause this while I write these. There, that saved us a couple of minutes. So I've listed all my possibilities, and I've already looked at the graph. And these are the only 2 of my possibilities that look like will work. Now, I do see 2 other roots on here, and it looks like at about negative 1.1 or negative 1.2, but I don't have anything around negative 1.1. This right here would be negative 1.5 or positive 1.5, but I'm definitely not that far. So I'm thinking these 2 are going to work. So let's do synthetic division with those 2 real quick, and let's see if negative 4 and 3 halves will work. So I have 2, 3, negative 23, negative 3, and 36. I'll bring down my 2. Negative 4 times 2 is negative 8. Negative 5, 20, negative 3, 12, 9. 4 times negative 9 is negative 36. And I do get a remainder of 0, so that confirms that negative 4 works. So I'll keep that as an answer. And then I will bring 3 halves through, which fractions are kind of scary. But if this does work, it's going to end up being sexy. So 3 halves times 2 is 3. Negative 5 plus 3 is negative 2, so I'll be negative 3 when you multiply. Negative 3 minus 3 is negative 6. 3 halves times negative 6 is negative 9, and I do get a remainder of 0. So those 2 did work, and since I don't think any of my other possibilities work, that means I'm going to go with this equation, which is now 2x squared minus 2x minus 6, and I'm going to set that equal to 0 and see if I can find my other roots with algebra. Set that equal to 0. I'm going to factor out a 2. That gives me x squared minus x minus 3 equals 0. And that's not going to factor. I would like for that to factor, but it doesn't. So guess what? The dreaded quadratic formula, which is just the thing you want to see after you've been watching a math video for 19 minutes. So x equals negative b, which would be positive 1, plus or minus the square root of b squared, which would be 1, minus 4 times a, which is 1, times c, which is negative 3, all over 2 times a, and 2 times a is 1, right? So I'm using 1, 1, and 3. So 2 times 1 is 2, and then I'll clean that up to 1 plus or minus the square root of 1 plus 12 is 13 over 2, and those are my other 2 roots, because we have 1 plus square root over 2, 1 minus root 13 over 2. So we have 2 rational roots, and then we have 2 irrational roots. They have square roots, and that's why my other two roots didn't look like they were in my rational possibilities. So there we are. There was one more problem I wanted to do, but I've already hit 20 minutes, and y'all are probably through now.